Cool. Thank you very much for coming. We're a little bit behind schedule, so I'd like to get started as soon as possible. Our next speaker, Jeff, I've known Jeff for a very long time, and the first day we met, we had a walk in Alaska. Jeff was on flip-flops, and I'm very happy that he's here now. Please go ahead.
Thank you, Walter. Is the audio good? I think so. So I'd like to go back about 2 years ago, not as far back as I've known Walter, but at the point at Travel Audience where I work now, we were in a process where many of you have probably been or will be at some point soon. We were migrating into Kubernetes. And so we, of course, started with the process of putting everything in Docker containers. And then for the Kubernetes infrastructure, we were managing it with Helm. So all the YAML configuration of an application was put into a Helm chart. So at the time, we had maybe about 10 services that we started with, and we created an umbrella Helm chart to manage all those the 10 services we had. So this umbrella chart had the configuration to deploy each of those 10 things into our production environment. And so the benefits here is that we could take this umbrella chart, deploy it into production, deploy it into a staging environment, or if the developer wanted to work on something, they could deploy the same thing that we had with just some small configuration changes, and everything was deployed nicely. However, this didn't work so well. The umbrella chart is broken. It doesn't scale. As we add more services to it, it becomes a big entity that Helm itself has trouble managing. And the other problems were that the individual release cycle of an application, being able to just say, hey, I want to roll this out, then dependent on rolling out this bigger umbrella chart. And so we had some reasons for taking away the umbrella chart and then having a nice CI/CD process that took an application directly into production. And that was fantastic for production environments, but we lost the reproducibility of our umbrella chart. We couldn't just take all those 10, now 20, 30 services and create a dev environment with them, because we needed to know which of those 10, 30, am I missing something? Is there something new that's come that's critical for my environment? And how do I set it up in my dev environment? So I began looking out in the community, trying to find some tooling that provided such a solution. And I found some blog posts of other companies who had the same problem. They described exactly what I wanted. They wrote a tool for it, gave the tool a really fun name, and failed to open source it. There was actually nothing available for me to work with to be able to do this. But everybody else had this problem. So, of course, we're sitting there with these empty shelves, wondering what to do. And at Travel Audience, thankfully, the management agreed, hey, we do need something to provide this functionality to our developers. And they also agreed with the concept of, let's put it back out in the community. Let's share this with everyone else. And so before I get into how to create your dev environment, the question is where? So at Travel Audience, we run everything in the cloud. We use Google Cloud. And so we have a dedicated project in Google Cloud where developers now have greater access. They can deploy things and do what they want that they wouldn't be able to access and do in our production environment. So for us, we're able to have one cluster with many namespaces for each developer. This might not be a solution based on costs, whatever. And so your next best option is to run these dev environments locally. Now, 2 years ago, running a Kubernetes locally probably meant Kubernetes the hard way. You had to learn what Kubernetes is, how to manage all the moving pieces of Kubernetes itself, just so you could run your application. Like, that was not sustainable. Minikube was around then, but it's come a long way to make it more usable. It's much faster. It provides Docker image support now, I believe. It's been released. And this is usually my tool when I'm doing something locally. However, there's some other great tools out there. If you're on Mac or Windows, then Docker for Desktop is an alternative to Minikube for running Kubernetes on your machine. MicroK8s is a tool that's really good if you're running Linux, but also supports Windows and Mac OS. And basically, these are the equivalent alternatives of Minikube, where you just have the full Kubernetes infrastructure running on your machine, and you're able to play around and do things as you need. There's some interesting tooling out there for running Kubernetes in Docker. So basically you have Docker running on your machine, then you put a container of Kubernetes running, which in theory you could have another Docker image of Kubernetes and then another Docker running Kubernetes. And you're in this inception model. You have to spin the top to find out if you're on a real machine or not. But these ones, I haven't used them on my local machine for running Kubernetes. I know that can be done. What's really cool about these is they run great in CI. So if you have to spin up Kubernetes to run a test on some application you're doing, these are a great solution for pretty much any CI tool out there. Will allow you to run Docker, which therefore will allow you to have Kubernetes to do your testing. So now we have our place to run our dev environments, and I want to get into some of the tools that are available. I'm of course definitely biased, having been the main developer of Armador. There's some other tools I'm going to get into, so now this part of the talk will be much more tool focused and how these things will work for you. Armador itself is based on the concept of Docker Compose, but it works for Kubernetes. And so Docker Compose comes with this example app, which is very over-architected for what it does, but it creates something better than just a hello world. So we have this voting app that, as a front end, users can go in and vote for something. That saves to a Redis database. You have a worker process running in the background that's converted into Postgres data, and then another front end where you can see the results of the votes. So very over-architected, but it provides what we would have of this Docker Compose configuration on the right-hand side, or left, if you extract this out a bit more, you would imagine in your company the voting app isn't just one developer working on this, but a whole team of people. And this whole team of people doesn't need to know that there's a Postgres database, that the worker converts what they save in a Redis to Postgres, and that the port for the result app is 5858. Like, why do I, as a voting app developer, need to know all this in order to run my application to see if it's working? So what Armador does is it's based on Helm, and so each of these applications is a Helm chart of its own, and the voting app is included with an Armador file that indicates the dependencies it needs. So as a voting app developer, I need a Redis because I know I save my data to Redis, and I need a result app so I can see what's happening in the end. And when Armador starts running, it'll spin up, or it'll find these dependency charts in your voting app, look for those dependencies, find the result app that another team has worked on and created, and they said, hey, when you run the result app, you need a Postgres and a worker that converts it. And so everything you need gets compiled built out into a graph and deployed into your environment. So Armador takes your Helm configuration of your voting app and then fills out all the rest of the configuration of the apps you have. And it leaves out all the other stuff. So if you have 30 other services running in your production environment that do additional things of how likely will somebody vote for this and all this, yeah, that's not what you need to test the voting app itself. You just need this components. So Armador isn't the only tool that does this. And it was actually interesting, as I started the development of Armador, I found that one of the tools that somebody had blogged about and described exactly what I want came out as ASIL and was released in open source. It's like, I already started, what do I do here? But the functionality for ASIL is generally the same. It builds out the dependency graph of what you need, so it doesn't include all this extra stuff. And that was one of my key reasons for building something. And then it functions on Git webhooks. So as you create a new PR, ASIL will trigger a call to the ASIL server, which will then spin up an environment based on what's in that PR. And then as you update the PR, the environment gets updated, and then when you merge the PR and close it, the environment gets deleted. So if your use case follows into this presentation mode of what's happening in a PR, then ESO is a great solution. What Armador has slightly benefits over is that it's a CLI tool, and so you don't need the additional hardware to run Armador, you just run it locally, and it spins up the environment with what you need, and then you're able to hack it and get in and do whatever you want, and you're responsible then to make sure it's still working, that it updates as you need. So depending on your use case, these two tools are potentially the better of the rest. Now, that's my opinion. And if it wasn't for this concept of having a huge dependency chain of not needing everything we have in production in my environment, then I would find Tilt to be really fascinating because it not only provides a great UI, both in the CLI as well as a web interface. It ties into your IDE, so as you develop, the changes will get updated into your environment. And you get an aggregate of all the logs of all the things that are running in your environment. When something isn't working, it shows up in a nice UI interface. And the other advantage of Tilt is that it doesn't depend on Helm. The ESO and Armador are Helm dependent, whereas Tilt will function with just pure YAML configurations. But what you do need is to know everything that's happening. So you do need that full Docker Compose that describes the whole environment. So as your dependencies grow bigger and more complex, it becomes a little harder to manage exactly what you need in your dev environment. A popular tool out there that has been around for much longer and was there so before anything started was Helmfile, and this has the concept of what the umbrella chart had, where everything is there and all managed by Helm and deployed as kind of one instance, but it does deploy it individually, so you don't have that bulkiness, that's restriction to it. But the disadvantage of using Helmfile for your dev environment is if you're doing it across multiple namespaces, each time you make a new environment, you have to then make new changes to your configuration. So you can't just say, here developer, here's a Helm file, you can deploy it if somebody else has already deployed that same thing. So it's a fantastic tool for managing a production environment and your configuration and knowing what's there, but having that dev environment usage might not be the best use case. A tool that came out of a company in Berlin, where Travel Audience is also located, is from Garden, and they actually started a while ago, but didn't come out with public, usage until after all this started a year ago. And what they have is similar, where they'll build out a dependency graph of everything you need, but the configuration seems to need to be kind of contained in the one general location. And so I haven't actually tried using it, but the fantastic thing with them is that the company behind it is willing to put in the effort and work with you to get it up and running. So if you're low on resources internally and want to be able to have dev environments, then contact them and get the support you need while they're at least doing it for free. So if you're dealing with a much less components, your dependency chain isn't so large, you just have one or two applications that depend on, I need a database with my front end, like that's kind of the scope of your existence with your development environment, then the Scaffold is a great tool. It ties directly into IDEs with VS Code and IntelliJ, and it provides a direct environment for the developer, handles all the file syncing directly and in a faster iteration process. But where it lacks is the bigger dependency chain. So again, use case dependent, this might be a good solution. And lastly, at least alphabetically, is Valero, which was originally developed by Heptio and called Arc, which then would have been first alphabetically, I think. But its concept is that it creates a backup of your cluster. And there was actually just a talk a few minutes ago about Valero, and so I can't really do what was probably talk about it in the same way. But what you can do is when you have this snapshot of your cluster, you can then just deploy that into another cluster, right? And then in another cluster and another cluster. And so then you have your ephemeral environment that you can just tear down and create because you have a backup of it. What I don't see working. I don't know, maybe it was described how you can manage this, but in your production, you probably have hundreds of pods, thousands of replicas, big persistent volumes, things that when you take that snapshot and put it on your local machine's not going to be able to handle the scope of that. So the dev environment for Valero might not be the place for using it, but it is a good tool that has benefits. So this wouldn't be a good tech talk if I didn't try a live demo. And I'm going to have a go. At doing a demo of Armador. So we have the Armador repo, and in this Armador repo, there's a docs folder with the example. And basically, everything in here is as I described already, how it functions. There's also a blog post about what's happening and the reason for Armador. And then at the end, there's really just simple one line to get it up and running, this example app. And what's happening inside is, actually, I already cloned the code. So and we have our example apps, and so there's the result and the vote app, because these needed to be included because these are our internal company apps, whereas the Postgres and the Redis, those are external upstream Helm charts, and the worker chart as well. The folks at CodeFresh, I believe, already packaged this example app into Helm charts, and so we just took the examples that they gave, and we can pull down their worker chart because we're not making any changes to that. So if I locally go into my I'm going to copy the voting app from and so this is, in theory, my whole functionality of the voting app would be in here, including my Helm configuration, including my YAML file, which lists the dependencies from the upstream stable repo, and the result app, which is a local repo within our company and has a specific path to the configuration. And I just run Armador create Jeff. And I'm assuming I have Minikube up and running already. Yeah, save some time there. And here you can see that these 5 charts are going to be installed. So this is the components that we need. And there, they should all be running. So kubectl get pods. The Redis and the database are on their way to being running. And the way Minikube works for being able to access your ports is by having a Minikube service. Oops, I was going to try to show the help here. So it creates URLs that are dedicated to the applications that are running in your cluster. Right? So kubectl get service. So I want to be able to connect to the voting app and cast my vote. And this cluster IP is only located within the Minikube, but if we forward out that traffic, it loads it up, and now I can vote for dogs, because I like dogs. Still gotta... And play from current slide. So now we have a full set of tools available in the community. I kind of just gave you a tool dump. I can say what's best for you is, of course, Armador. But again, find your use case, find out what's available. What's most likely the case is now that there's all these tools, you probably don't need to go through the trouble of rewriting your own. You can instead work on what's available. And I have a talk tomorrow where I'm going to discuss what you can do now that you have your ephemeral environment, now that you have this dev environment. How do you debug and how do you actually use it to the best you can? And I just want to give a shout out to the Helm contributors. The maintainers are going to be giving a talk at the config management camp. Thank you.